Now in this video we'll talk about PIM protocol independent multicast. Like if we quickly revise what we discussed in the previous sections, in the previous section we have seen some IGMP protocol. Now IGMP is a protocol which is used to communicate between the host, the receivers and the router. So whichever the receiver wants to receive the multicast traffic, probably they need to send some join messages to the router. And now the question is that router, how it is going to reach the server from where it is expected to receive the multicast traffic. Now the router has to figure out how to reach the server. So which means we need some kind of routing to be done here, and that is what multicast routing comes into picture here. Now the multicast routing is done by different protocols we can use, like distance vector multicast routing protocol and multicast OSPF protocol. These two protocols are legacy, which are no more used, and in today's network we generally use something called PIM, protocol independent multicast. Now this PIM protocol is responsible for routing, multicast routing, or used by the router to figure out how to reach a multicast server, or how the multicast traffic should come from the particular server on the WAN. Now PIM stands for protocol independent multicast. It provides a loop-free router-to-router communication, and it is not going to advertise the routes just like we did in RIP, UHRP, OSPF. Here we are not going to advertise any routes here, but instead it is going to still rely on the IGP protocol to figure out a loop-free multicast routing. So it's going to figure out based on some RPF check. We'll talk about RPF check more in detail in the next sections, and it's not going to advertise the routes throughout the network like IGP. So PIM is going to operate in two different modes, and there is something called PIM dense mode and sparse mode. So let's try to see the difference between the dense mode and the sparse mode here. Now the mode exactly tells how the multicast traffic is going to be sent from the sender to receiver. So let's say I have a sender who is sending the multicast traffic, and I got some receivers somewhere here, and how the multicast traffic is going to be sent. Now the PIM operates in two different modes. The first one is a dense mode. Dense mode is a simple and very straightforward concept which works based on flood and prune behavior. So let us get into more in details on how they exactly operate. Now in case of dense mode, the server is going to send, it works with something called implicit join, where all the portions of the multicast network will receive the traffic from all the servers unless you specifically say you don't want it. Like let's say I have a server here. Initially, if this server is sending a multicast traffic for a specific group address, let's say, it's going to send out of all the interfaces, and the router is going to send out of all the interfaces. Again, it will send out of all the interfaces. And in case if there is no receiver here, I have no member who wants to receive the multicast from this so and so group, it's going to send a prune message, and then the router will stop the multicast traffic. Now that's what we call as implicit join, and it is going to use something called flood and prune behavior, where the multicast traffic is initially flooded out of all the ports, and if you don't have a receiver, it's going to be pruned automatically. Now this design is not really applicable for very large networks, because it is something not efficient to send out the traffic everywhere to figure out again where it doesn't want the traffic. Now the next mode, we have something called sparse mode. Now in the case of sparse mode, it's not going to work based on flood and prune behavior. Let's say I have a receiver here, and I have a sender who is sending the multicast traffic, a server. Now here the router is not going to flood the traffic. Instead, they both will join us to something called rendezvous point. Now we are going to configure something called some router or a device referred as a rendezvous point. Now this rendezvous point is the root of the forwarding path and where all your join messages will go. And this rendezvous point, the RP will decide how the traffic should go from the source to receiver. Now, if you have any receiver who wants to receive the multicast traffic, they need to send a join message probably to the RP, and the sender will join to this. Now, RP will decide how the traffic has to go between the sender to receiver. So we'll be getting into some more in details about these modes with a practical verification by enabling it. Probably just there are two different modes where we can run the protocol PIM. Either we can go with the dense mode or sparse mode. Now the dense mode, initially it is going to work with something called flood and prune behavior, where the multicast traffic is initially flooded, and if anyone do not want, it's going to be sent a prune message where the router is going to stop the multicast traffic for that particular group. And that is something not applicable for big size networks. Whereas in case of sparse mode, we are going to configure something called rendezvous point, which is like a route, and it's going to decide how the traffic has to be sent from sender to receiver. Now it's like, the sender and the receiver has to register themselves with the RP, and the RP will decide the actual forwarding path from sender to receiver.